Welcome, guys. This is the part 2, and we will further discuss about the drawings in detail in this part. If you have missed the first part, then you can always go to my first part and enroll in this one. I have given the link in the description, but if you can check the content of first part if you know the topics already. So I welcome you in the second part. So I'm starting the second part by a topic: how to read drawing using cross references. So I have given a brief introduction in the first part about this point. This is very important. This part means it's just like that you are reading maps. You if you can read the maps, you can read different streets from one place to another place, how you can go. So this is of that much important. Okay, so let's start this topic. How to read drawing using cross references. This point is extremely important. If you understand this point, you can go through complete drawing. So the idea is if you cannot understand the drawing in the start, don't worry about it. You just try to go through it, because your brain is getting trained. So even you are not unable to understand, just read daily. So after 1 or 2 weeks you will be start to pick up, and then you can easily move to the second topic, second stage, and you can start understanding schemes. Each loop is marked from where it is its source and where is its destination. So the key idea is each and every loop in the drawing is showing the source from where it is started and where it is terminated or destination. So unless it is the last point or it is the first point. So let's check the drawing further. I have make a screenshot for you. So this is the page. Here you can see this L1 plus is the DC loop. This I have explained in my last lecture. And this is a DC loop which is coming from 20.3, sheet number 20, column number 3. So you can go to the next sheet and then you can find that this loop is terminating to the current sheets. So let's go. Okay, now this is the sheet number 20. I have opened here sheet number 20, and here you can see there is a MCB, and through this MCB this is the terminal block X102 1 and X102. This is the terminal block. This is MCB. F201 is MCB, and 3 and 4 are the terminals of MCB. You can see here, this is the thumb rule in the drawing also, that odd number is incoming, where incoming power circuits or cables are connected, and even normally is used for outgoing or where the circuit is terminated. So if you see here, this one is just, I will brief you and you can further understand yourself, or just wait for my next part and I will keep on explaining these functions also. This is a changeover scheme. If one supply DCs fail, automatically it is change over to the second supply. So this is just introduction. This is the auxiliary contact of this MCB. This is changeover contact, and if you want to see where this contact is connected, you can always go to sheet 21.3, and this is the contact of F201. Luckily F201 is available here. So you can see here, this is L1 plus. Plus means the positive supply of the DC system of the loop, and this is a negative supply. So it is terminating to 30.2. so 30.2 is this sheet, and it is coming from 20.3. so 20.3, just go to 20.3, and I have seen now this is sheet number 20.3, and this is the supply coming. So this is very basic information I have given you. all the drawing is shown like this. Sheet number 30 is first sheet number and 1 is the column number. Sometimes they are also showing the row number in the drawings. So this is how addressing is done and references are shown. Okay, in another example is this loop is further continued at page 31 column 1. So this is the loop L1 plus, and this is the arrow sign, and this number is showing that this loop is further continued to sheet number 31 column number 1. Okay, now we will go to a drawing, and further I will explain you in the drawing. We will discuss some cross references. Okay, now I have opened a drawing for you, and we will try to see the cross references. Okay, this is the AC supply, phase and neutral, and this is coming from external source, as I have explained before. This dash and the single line, dash and single line is showing that this is not the part of the panel that we are reviewing, it is an external source. So here you can see at external source no information, no panel number is mentioned. So we can say here the external references are missing in the drawing. Okay, so once it is terminated from external, one it's entering in the panel, it is terminated to X17. This is the terminal block number X17, terminal number 1 and 4. This is phase, this is neutral, 230 volt AC. And then further it's going to MCB F101, which we will be calling as an AC MCB, and it's again coming to the odd number as we have discussed, and as an incoming supply and outgoing is connected to an even numbers. Then from MCB it is coming to switch, which is just like a button. It is basically a door switch in the panel. When door is open, the light will be on. This is the light, and when door is closed, light will be off. So it means that this switch, normal position of this switch is when door is open. So by this way you can learn yourself what are the normal positions of different equipment shown in the drawing. I have explained you the normally open and normally closed positions of different components, and here how you can learn yourself. This is the normal position. So normally what happens when we are doing the maintenance, we are opening the panel door and we need light. So this is how it's working. You can see here F101, which is this MCB auxiliary contact, is wired up or used at 40.7. So what I will do, I like to see where they have connected the auxiliary contact of MCB. So here MCB is shown in off position, which is normal position for MCB. Door is in open position, and it means that MCB is tripped. So if MCB is tripped, it should give some alarm. Means the scheme will be like this, that if this MCB is off, tripped by a fault, or if somebody has forget to switch it on, this contact will operate 11 and 12, and then alarm indication will be given to annunciator panel or some automation panel or computer screen. So let's go to sheet number 40.7. so you can find sheet number on the right bottom. So we will go to 40.7, 31, 33, 36, 7, this is 40.7. so here is this MCB auxiliary contact, and if you see the naming here, it is relay panel AC supply MCB tripped. So this is the MCB, one is for lighting, one is for heating, and they have wired up the contact, normally close contact, again normally close contact of MCB. Normal position of MCB you should know is open position, so it means it has stripped. So then it should give supply. Supply will come from this annunciator panel. This is the annunciator panel. CP bay number E01. CP for control panel 30 is the panel number. So supply is coming from the panel, which is obviously a DC supply. When AC is failed, the annunciation normally done by DC, and when DC is failed, annunciation is done by AC. So there are two type of annunciator in the substation, which are operated by AC supply, and some annunciator operated by DC supply. So you can see this dash and the full line, which are called as reference lines, showing that this component is not part of the panel we are reviewing. This is the another panel, external wiring. So you can see here cross reference is mentioned. The common supply is coming from X1913 from the panel CP30, and it is coming to our panel, and the panel is RP30, relay panel number 3, terminal number X11-9, and from here this common supply will be connected to F10112, F10312. These are both AC MCBs. If any one of the MCB trips, then this contact will be made and the DC will be through. If both are on, this contact will be at 11 and 12. If both MCBs are on, 11 and 14, position of contact will be from 11 to 14 and from 11 to 14, because it's a normal close contact. And when MCB is in off position, then it will be at 11 and 12, and supply is available here. When MCB trips, the contact position, changeover contact will move from 14 to 12, and then DC supply will further flow downside, and it will back to give the indication to the control panel that now MCB, AC MCB is tripped. Voltage will appear X941, and then from there the voltage will be connected to some window, some lamp on the control panel that will glow, and it will show that AC supply of the AC panel is failed. So going through this example, your assignment is you can go through this drawing. If you can understand or cannot understand a component or scheme, don't worry, just go through it and improve your skills of understanding from page to page. So first of all, I will recommend that you should trace all the DC loop of the drawing, AC loop, DC loop, and might be the CT circuit, VT circuit. So this will be your first assignment. Go through it and don't worry even if you miss or don't understand it. Obviously it will take time to develop the mind understanding. So I will once we finish each component of the component understanding and each piece by piece the drawing, after that I will go through the complete drawing, and if you are following with me, you will be able to understand fast and easy. Okay, thank you.